Thanks for having me. And thanks for staying for the last talk of today. Thanks for the introduction. I have just one minor correction. I'm from the Hamburg office now, but that's just a little thing. Yeah. As you can see from the title of the slide, the original headline was Teaching Sensible Defaults to Coding Agents, but it has undergone some refinement. And I narrowed it down to test-driven development. And this reflects a little bit my own journey and experiences with AI coding tools. So when I started working with them, it was quickly clear to me that we need some kind of way to teach them craft and sensible defaults. So the stuff that we value in software development. But it became, I would say, obvious or clear to me that the starting point for that should be test-driven development. And yeah, focusing on that also fits into our time slot of 15 minutes here, I hope. And conveniently, it looks to me that TDD is having some kind of renaissance right now. More and more people are talking about how they use it with agentic coding. So I think it's a very interesting topic to have a look at right now. So let's dive in. When you first start using agentic or AI, I use this interchangeable in this talk. I think it doesn't make a big difference here, coding tools. So everything feels fresh and new. You don't have to write all this boilerplate code anymore. Everything is created for you. Feature after feature is added at very fast speed. It's very cool. You can get easily pulled into this vibe coding mode. You just type what you want and you get the results, and you don't really bother checking the source code. And I think it's not for nothing that some people compare this to a slot machine. It can really get you hooked fast because it's just so fun. So what could possibly go wrong? Turns out everything can go wrong. It goes downhill very fast, as fast as it goes uphill, I'd say. So you ask the agent, yeah, please fix that bug, but it doesn't do it. Instead, something else breaks as well. You have just a mass of spaghetti code. You look into the code after a while of vibe coding, and you just see it's just everything is duplicated. Everything is a mess. And what makes it worse is how these agents are designed to have always this pleasing and nice language. Everything breaks, and you get a very cheerful, yay, you're right, I fixed it, and nothing is fixed. Just yesterday, when I was finishing up my talk, I saw in one of the Gen AI Thoughtworks chats the very same example of that, where the agent said, yeah, we are at the very beginning again. And it just makes you furious, right? And I think this whole situation, it reminded me of situations when you're working with very inexperienced developers, for example, interns, luckily minus any yelling, I have to say. And when very inexperienced developers are left alone on a code base and they're given new task, add this feature, please, add this feature, please. But if nobody has the time or the insight or the initiative to actually guide them and to review their code, they will run into the same situation very fast. With the difference that the AI tools run into the situation much faster. So if you've been following this field a bit, I think this idea that I presented of the AI tool as an overconfident junior is not so new to you. Our colleague Birgitta often uses this example in her explorations of the topic. So she talks about the concept of anthropomorphization. This is our tendency as humans to project our capabilities and features onto our tools. And I'd say with AI, this is a big risk in a way, because it muddies the waters a bit when we always talk about computers of like understanding, having feelings, all this stuff, because it kind of confuses our understanding of the technology. But on the other hand, you can also turn it around and use it as a mental model to understand the problem. And we can use it here right now. So imagine our AI teammate as somebody who's very eager to help, but also very stubborn once it started on the solution. Somebody who's extremely well read. Like the models have been trained on basically the whole corpus of written knowledge, the whole internet, code, books, whatever, but at the same time being really inexperienced. So I think the question here is, like, when a junior developer produces bad code, who would you say is at fault here? Would you say, yeah, it's the junior's problem, they just didn't do it right? Or would you say, no, it was our team's fault, we did not guide them? And I think in our case, maybe this is where the metaphor needs to be stopped in a way, because despite having this name agentic AI, there is no agency in these tools. So, and something which has no agency cannot be at fault, like by definition. So if the responsibility is ours, then that opens like the question, what's our tried and tested approach for guiding software development and for ensuring code quality? And I think this is like where we have to go back or revisit. We have all these decades of research and writing about how to write software. And the question here is how to tap into this for AI coding tools. And I think here's the core issue. Those AI tools are very good at producing code at a huge amount and at incredible speed. But what they are very bad at is what we value a lot, craft and engineering excellence. And some people might say, okay, this is a big contradiction here. Those tools are bad for our craft or for our profession. But I don't think that's a contradiction, and I don't think that's a problem here. I think, on the contrary, this is a huge opportunity. It's actually like a perfect fit. We just have to explore how we combine those two strengths. And to get you started on my solution for this problem, I'd like to prompt you with 3 questions. My first question is for you. If somebody asked you about 5 must-read books on software development, what would you answer them? What books would you recommend to them? You have to read this or that book. But the second question is, if you had to describe in a chat message to a team member or something, everything you learned from those books in just 5 paragraphs, how would you go on there? What would you write down and in which order? And it's the third question, what would be the first principle you'd start with? So you have maybe already guessed, I'll start with test-driven development here. I don't think, I think I just skipped the slide because I think everybody here at least have heard of TDD. I guess most of you have been working with it daily. I think a couple of you are just practicing TDD right now in another window because they underestimated a 1-point story yesterday and have to get something done real quick. So the point of TDD is that you can write it down in a very short and concise way, how you do the red-green refactor phases with your tests. And this is this is where I experimented. So a quick clarification here. When I say teaching is maybe close to learning, and learning, deep learning, I don't mean retraining or fine-tuning models in this case. I mean using the context window of the models, which is rather large for bigger models that we use right now, to provide instructions that are sent to the model with each prompt. And I think all of the AI tools allow you to do this with markdown files nowadays. So depending on your editor, it's the wording is slightly different, but the interface right now is some kind of markdown file where you can put down your own rules or constants that you want the tool to follow. So the challenge here, I think, is, I mean, we have a huge context window, but the challenge here is not to dump in a book or 10 books into this context window, because that's not needed here. The challenge is how to really distill it down as a guide for this entity, so to say, which is already well read, which knows all the references to the stuff, but which needs a constant reminder to stay on track to use this best practice. So this is where I started experimenting around a bit. I re-scouted a little bit of books, of blog posts, and thought, okay, what would be the stuff I would put down in a file called codecraft.md to reference it to my agent. And yeah, you can see on the left, I started with a description of TDD. I put in the middle this behavior-driven development given when then pattern for acceptance criteria, because I like to structure my tests like this. So I like to read them like this and to understand them. So yeah, you can put in your own flavor of working or understanding in there. And I put in some other paragraphs about, yeah, you can see them on the right, only the headlines, small incremental changes, fast feedback loops. I omitted a bit of the text here because I don't want to stare at the wall of markdown with you together, but just to give you an impression. And on the right, there are, I found on Martin Fowler's blog, I think it's just a direct quote from an extreme programming book, those design rules, because I also like them that they're very concise and to the point. And yeah, I started working with it, and yeah, it worked out rather well, I'd say. And when I was 1 or 2 weeks into my explorations, a podcast episode with Kent Beck came out on the Pragmatic Engineer podcast, accompanied with a blog post by him, where he described the workflow, which was very similar to that, and provided a system prompt, which also looks very similar to that. So in the beginning, I was a bit bummed out. So yeah, I started experimenting with the stuff. I want to do a talk here at the festival, and then yeah, Ken Beck just does more or less the same, but just he has like 10 hours a day time to do vibe coding, to re-implement the web server and Smalltalk and whatnot. So, but I still thought, okay, maybe this just shows this is an interesting topic, and this is a topic that we also need to have a look at. So I will still present it to you and show you how this all works together. And quickly afterwards, it turned, I think it kind of turned out that TDD is a little bit of a superpower for AI code, so to say, because apart from Kent Beck's system prompt and blog post, the major vendors of those tools started mentioning TDD in either their trainings or in the documentation. I saw in our chat spaces a lot of messages popping up about people experimenting with TDD workflows. Yesterday in the IME version of our festival, our colleague Jem gave a talk. The title is Making Klein Less Clueless, A Guide to Sensible Defaults. So people in different regions seem to have the same ideas, and I talked with him about it. And it's also right now still a markdown defined structured workflow, which includes TDD to work with Klein, which they are using in different projects already. And I think there are a couple of reasons why TDD is really helpful for working with AI tools. The first reason is it anchors down the development to concrete behavior. Like whether you write the tests or have the agent write the tests, you are forced to define and to codify the desired behavior before you begin your implementation. And the second reason is it catches regressions. So AI is probabilistic, and we want this, we need this to generate code, but it can be really frustrating if it introduces bugs. And having this test suite ensures that the implementation, sure, it can change, should change, but the behavior that you nailed down with tests remains constant. And the third reason is a bit similar, maybe. We have a fast iteration loop with AI tools. They are really quick at producing code, but we need to narrow them down and to steer this iteration loop. And I found this quote in the Anthropic guidelines: Claude performs best when it has a clear target to iterate against, and we can provide this clear target here. And maybe the secret fourth reason, which is just popped up in my mind yesterday. I think a lot of developers, secretly or unconsciously, feel that TDD is great, yeah, but only less clever people should use it, because I am not intending to write bugs. I don't write defective software, so I'll do the test later. But those people who are less good at programming than me, they should definitely use TDD. And with AI tools, we have the great unique situation where everybody agrees that those tools, they are clearly less clever than us. So they should definitely use TDD. So this is maybe just some mind trick for having having a reason to use it. And I think it works rather well. But yeah, to give some outlook, because we were talking also about sensible default and maybe the broader picture, I don't think TDD is a silver bullet for AI coding. I mean, you can have your test suite and you can still write spaghetti code and patch one feature onto the next if you don't design deliberately. So I think there are a couple of challenges or ways to improve ahead. And the first one is still narrowly on the TDD territory. How can we make it non-optional for the AI tools? Right now, a guideline in a markdown file is not binding. So nothing stops an agent which is stuck on a failing test to just alter the test, to just return true somewhere, something like this. And in this direction, I've seen at least some experiments where you really programmatically lock down those files in the process. Like in one half of the process, you lock down the source folder, and in the other process, you lock down the test folder, and you run a diff on it and revert and tell the agent, no, it shouldn't be changed. So enforcing this with your tools to not get tricked here by the fuzzy nature. The second question, as you could see in my file, I experimented a little bit with other stuff. I tried edit rules for example, for solid or for patterns, for coupling, but I couldn't see much difference in the agent output. And I think code design is a more nuanced problem and something that we would also argue more about, while TDD is rather straightforward. And I don't really know, yeah, how this will be gapped right now. And I think like doing this design work is still something that we have to bring to the tool and to the process. And the third question is also how do we move from tactical to strategic code creation? This is a concept from John Ousterhout's book, The Philosophy of Software Design, where a tactical programmer just solves the task at hand by implementing a feature. And the strategic programmer takes a bit extra time to reason how this feature fits into design of the system, how the design could be improved while adding the feature. And right now, I think the tricky part is we want our agents really not to be strategic. We want really to have them hyper-focused and not to refactor everything. And I think this is the part where maybe the human software development and the AI software development kind of fork right now. Maybe until, which can also be very fast, until we have more capable models. But yeah, I'm not sure if we want this strategic thinking to be done by the AI tools right now. So yeah, this is my call to action for you. Let's evolve this together. Start with some instructions. Use mine or use Scanback system prompt, or I think even better, write down your own unspoken ideas and knowledge about software development, feed it to your tools, experiment with it, and share it and discuss what changes in your workflows. And I think this is a valuable exercise, like apart from creating code, because we talk about best practices, but like being forced to write them down in a very concise way is really interesting also as a lesson for us. And I think when we create the small artifacts like for different code practices and share them, combine them, and build a library of those small markdown snippets, that could be really interesting. So I hope this has been an interesting introduction to the field to you, and that you feel inspired a bit to experiment with these tools.